All right, so what's the difference between collection and a retrieval? And basically what I'm talking about here is collection. What I refer to as a collection is sort of that imagery, that video, that remote sensing collection. So what I mean by remote is we don't actually have to touch the object that we're collecting information about, all right? So we're going to use camera or some other sensor to collect information about something. That's collection. Where retrieval, we're actually going to use some type of payload that's going to allow us to go fly to a location, use that payload to actually extract something, and then bring that payload back. It's either analyze what the sensor has sensed about that extraction, or to actually pull some physical medium from that payload to run some additional analysis on. All right, and so let's fill in the gaps here. So the UAS has revolutionized data, intelligence, and material gathering because of many attributes, all right? And this is not an extensive list, but it probably is the most, these are probably the most important attributes of a UAS that would lead to this sort of revolutionized approach in many fields of science, industry, military, the way of doing business, collection and retrieval. All right, so first attribute pertains really to all the advantages of being positioned and moving through the air. All right, so if we want to collect visual information about something, many times that perspective from the air is a very quality perspective. Not always, right? We might have a target beneath a tree or in a building, right? In that case, using a UAV from the air maybe not offer the greatest advantage, but in many cases that viewing perspective from the air provides a great advantage. All right, the other thing we can do from the air is we can avoid obstacles, right? We can fly over obstacles, we can fly around obstacles, we can avoid detection. So if we want to, if what we're trying to observe, if it knows that we're observing it, is going to provide some disturbance, then we can avoid detection. And really what I'm thinking about here is like wildlife observation, other birds coincidentally, or any type of wildlife. But also there's the defense side where we want to spy on foreign operatives or whatever we want to do, and we want to do that in secrecy. Having an observation device in the air is really good for that. And of course, travel by air affords us a very quick mode of travel because we can, usually the shortest route between point A and B is a direct line, and if we're in the air, usually that's our best opportunity to use that straight line. All right, so the other advantage of UAS for collection and retrieval is maneuverability. All right, and a lot of these things, some of these things really overlap with delivery as well. Just keep that in mind. But maneuverability in environments where other equipment can't access safely or at all. And one of the examples that I'll point to for retrieval is, and I apologize that this just sticks in my head because of the very familiarity with me, but retrieving that water sample out of the lake at the bottom of the Kilauea volcano on Hawaii's Big Island. And if you're like, yeah, where did I see something about that? The homepage, on the homepage, I actually offer a little sort of storybook about the work I did to do that retrieval, right? So there's no other way to get down there. You can't get down there by foot because there's like 1,000, or I think it's like 600 feet of scree that just sort of funnels down to the lake. So there's no way to get down there by foot. It's at the top of a summit where there's a huge 1,000-foot pit, or it's deeper than that, but so the air patterns and steep slopes make it impossibly dangerous for air travel. So UAV actually is the only object where this water sample becomes a possibility. Of course, the third attribute is no risk to life, right? And there are a lot of different things we can do with the UAV that are typically done with manned aviation. And the difference is we're not risking someone's life by flying a UAV. You know, we're just risking, even if it's an expensive aircraft, by the standards of how human beings, some human beings value life, it's really no contest. All right, and then usually UAVs or UAS is going to offer us a cheaper way to do things that could also be done with manned aviation, right? So there are a lot of comparisons here with manned aviation, and sometimes manned aviation is the way to go. I want you guys to keep that in mind. UAS is not the answer for everything, namely if your collection covers a very large area. When we get into large vehicles, typically manned vehicles are cheaper to operate. Like a Cessna is cheaper to fly for a few hours than a Predator, for example. Predator is pretty expensive to fly, requires more people, more resources. All right, so when we're talking about collection retrieval, let's talk about imagery versus materials. This section focuses on two categories of collection. So imagery collection and materials collection. Thanks for joining us, Matthew. All right, so imagery collection. So, this is my wheelhouse. I'm a remote sensing, I came from the world of remote sensing. I'm a remote sensing scientist. I guess technically I'm more of a geospatial scientist. Remote sensing sort of rolled in to things. Jonathan, did you mean to? Okay.
Yeah, no, I accidentally pressed that. My bad.
No problem. I figured. I figured you'd voice up if you're like, hey, I got to show you something. So. That's cool. So imagery collection, not only, so that's actually how I got my job, right? I actually work for a small unit within the Department of Interior whose primary focus is aviation safety, right? And so when they made the request to reach their footprint out beyond, so to hire a couple remote sensing scientists, so myself and another colleague, the question was, well, you guys, your focus is on aviation safety. Why would you need to hire someone skilled with remote sensing? And the wisdom from my boss was like, look, if you're flying a UAS and the sole purpose of flying the UAS is to collect data. If you're not collecting data the right way, that's forcing you to fly the UAS more, either more often, more repetitions, or just having to repeat projects because you're not collecting data the right way. So imagery collection ends up being very important into a lot of different aspects of the UAS beyond really just focusing on the imagery collection itself. But the imagery collection is one of the most, it's the most common reason we're going to put a sensor or payload on our UAV, and that that payload or that sensor is the #1 reason we're flying a UAS project in the first place. All right, so that is the most common utility of the UAV is the photo or imagery collection. Remote sensing, so one of our terms for the module, the process of data collection from a remote perspective. So it's basically saying we're trying to learn about something without touching it, right? And so the best, I guess the most common way we do that with the UAS is to use just a camera or a video recording device. So let's talk a little about those devices. So there are a host of available sensors to observe the environment, and I'll break, typically in remote sensing, what we do is we break sensors down into these two categories. And again, there are a lot of different ways to slice and dice these different tools. But in remote sensing, traditionally what we do is we say we have passive sensors and active sensors. So passive sensors are sensors that can collect information from existing radiation. So for example, the sun's rays shine down through the Earth's atmosphere onto a tree. We fly a UAS over that tree with a camera mounted on the UAS, and that camera is sensitive to the sun's rays that are reflecting off the tree. So that sensor is a passive sensor. It doesn't have its own energy source that it's beaming to the tree and sensing. It's using existing energy from the source that we're interested in observing to sense properties about that object. Where an active sensor is the opposite. So active sensors, and I'll just throw out a couple terms that I've been asked about over the course of the semester. So radar and LiDAR. So what these sensors actually do is they have their own onboard power source that sends out some sort of energy. So with radar, we're sending that electromagnetic radiation in the radar wavelength out. That radar is going to bounce off the target and then be reflected back off the target back into our radar antenna. That radar antenna is going to interpret, or the onboard sensor is going to interpret what the radar antenna receives and produce some information about that object in the radar electromagnetic spectrum range. Same thing with LiDAR. LiDAR produces a pulse of light that goes out, strikes an object, bounces off that object back to another aspect of the radar, which collects that light and gives us some information about that object. So those are active sensors. And if you guys want to check out this link, U.S. Geological Survey has a couple UAS mounted LiDAR that they use for various projects. And this is an example of the West Coast, the Big Island. This is unrelated to any of the other Hawaii work that I've talked about thus far, but kind of cool to see a little perspective of this project. Not only demonstrates how we can synchronize imagery collected from LiDAR with imagery collected from traditional camera methods, but they also incorporate some land-based LiDAR, some terrestrial LiDAR into their study and assessment. All right, so next thing I really wanted to talk about is the camera gimbal, because this is really a very important element of any UAV mounted sensor or camera, primarily because, you know, the UAV when flying is going to be subject to a lot of turbulence and a lot of vibration depending on, you know, we talked about like what is the material of a UAV fuselage created. So depending depending on that material, you're going to have a lot of vibration from your motors. And what the gimbal typically has two primary objectives, and one is to dampen vibration and noise caused from sort of the up and down movement of a UAV, either from wind turbulence or from vibrations from the motors. And the other main use of a gimbal is to provide access to observe a target that is not directly in front of a UAV. So if you think about flying a UAV with a camera mounted on the front of the UAV, well, that UAV always has to be pointed at the target for you to be able to observe that target. Where if we have a camera with a gimbal, oftentimes that gimbal can be used to actually focus the camera that's mounted to the UAV on a target while we can fly the UAV in a different direction, or actually loiter a UAV around a target and use that gimbal payload to actually observe the target. And it's really all I want to say. If you guys check out this image came from this article from Unmanned Systems Technology. If you want to learn more about gimbals, check out that link. It's a really cool short article. And you know, gimbals typically, when you see a gimbal like this is often called a gimbal ball, and each one of these little windows probably represents a sensor within the gimbal ball. So typically when you have a gimbal ball like this, you're talking big money, right? These are going to be mounted on really expensive UAVs because they're really expensive sensors. And you actually have multiple imagery sensors within a single gimbal ball. Now, not all gimbals are this complex, and I wanted to keep going with my 3DR Solo example and talk about the gimbal that sort of comes as custom. And I'm going to stop sharing for a second and just jump over and demo my Solo for a sec here. And gimbal foam removed. So here's the 3DR Solo. So the Solo, in typical payload, the typical payload that you could buy it without the gimbal came with, so they stopped selling the Solo. I think they stopped manufacturing in 2015. I think in 2018 they sold out. I don't think you can even get them on Amazon anymore, though you can still find one on Craigslist from here and there. But anyway, so the 3DR Solo came with this is the GoPro Hero 4 Black, and so this is the gimbal, and this is actually a they call this a 3-axis gimbal. And so what an axis does is a gimbal axis provides movement in a 90-degree view angle. So this is a 3-axis gimbal. So you can see if the aircraft is flying from your left to right, so nose is to your right. So we can see that this gimbal it's got about a 45-degree pivot left and right. So if the aircraft is flying at you, you can see that's one axis. The gimbal also can pivot based on if we had some roll. So if we're rolling left or right, the gimbal has the property of being able to mitigate that roll so we can stay focused on our target. And then we can also pivot that gimbal up and down with our controls on the GCS, the hand controller. So this is actually a 3-axis gimbal mounted on the bottom of the 3DR Solo. And I undid the screws because you can actually remove this gimbal and mount a different mount onto the 3DR Solo. This has 2 electrical mounts within the Solo. So this basically, this controller is, or this connector right here controls how we how the gimbal moves and how we can control the gimbal. And then this is simply our HD out so that we can send video from our GoPro to the onboard radio back to our ground control system so that the observer or operator can see the video. All right, so this is just the gimbal, and gimbal itself mounts to the aircraft up here. And so you can see, I don't know if you can see these little rubber grommets here. So these screws mount to the aircraft, but these little rubber grommets really are what, this piece up top is what is actually attached to the payload itself, where the bottom plate is what's attached to the aircraft, so that we do get some dampening through these little rubber deals there. And then we can also pull out, this is, let's see, I think this payload does work with other Hero 4 GoPros, but it has to be a Hero 4, but we can also extract the camera itself. It's got, the GoPro has this little mounting bracket on the backside, and then this little plug, that's what the HD plug goes into. And then for the Solo, we have that same connector on that goes into the back of the GoPro, and then our HD video connector right here that goes into the gimbal. We just talk about pictures and video for situational awareness. All right, so how do we define what the qualities of those pictures and images are? And I'm just gonna go real quickly. This is more in the remote sensing realm, just to sort of, you guys are aware of, like, you know, what are the differences between a video or a camera captured by drone A versus drone B. All right, and we can define our output imagery or our output video by these 4 resolutions. All right, so we have horizontal resolution, radiometric resolution, spectral resolution, and temporal resolution. And basically what these resolutions tell us is what is the level of detail that's available in each of our images or our video. All right, so our videos really, or a single frame image, can provide valuable situational awareness to take advantage of a UAV's ability to achieve that aerial perspective. All right, so we can use this information in real time to record and review images for production of a number of different products. This concept of collecting stereoscopic images, so overlapping images from a UAV, and then being able to mosaic those single images to give an overall perspective about a larger geographic range of a spatial object or phenomenon that we're interested in. You know, here are just some of the concepts behind the photogrammetric principles of UAS, and yeah, so check it out if you want to learn more. There are some details in here you can observe. I'm happy to answer any questions, but I'm not going to dive more into the subject right now. So next, really, I want to talk about materials extraction or retrieval. Okay, so maybe something you guys hadn't considered, or I think is definitely considered less frequently. When someone thinks about a UAV, you know, everyone thinks about, hey, I don't want that drone flying over my house because it's collecting imagery while I'm sunbathing. Now, I don't know why you guys would want to take pictures of me sunbathing. I'm old, but anyway, that's a big concern for people being concerned about UAVs and privacy. But there is this other aspect that's really growing, especially among scientists and science, this idea behind being able to use advantage UAVs, superior robotic access skills to actually go in and collect some data. And I just offer you, so really all I want to say is it happens, and I am going to ask you to watch a couple of these videos to answer the questions related to your Module 5 discussion group. And I do ask you to watch a couple of these water sampling videos. Yes, I am sort of unabashedly promoting just some of the work I've done, really that has nothing to do with it. I honestly feel like this is a very novel use of UAV, of UAS, and I first-handedly know how challenging this project was. So I think what I ask you to do, and I think what you could get away with, I'm not sure, like if you just read the question within the Module 5 discussion board, I think you could probably get away with watching this 2-minute 11-second video from the Big Island News video, and then watch this 3-minute video from Fairweather IT, who have designed this payload that sort of enhances our ability to do the water sampling, and then formulate an opinion and provide that within the discussion board. It might be that you have to watch this 11-minute video, which this image down below is actually taken from. So, and that's actually me on the rim of the Holly Mau Mau crater, which Kilauea sits at the bottom of now, and used to be this lava lake prior to 2018 at the bottom of the Holly Mau Mau crater, and now it's a water lake with nothing but sheer and tattered sides to it. So here you can get an idea. This is just a nylon rope lanyard, and we have a couple water scientists at the bottom in charge of the successful launch and recovery of the payload. The way we did this is I launch and back the aircraft up, where this is Dr. Frank back here, not Dr. Frankenstein, though they we joke that that's what they sort of looked like in their little green smocks. But this water is like 198 degrees Fahrenheit. I mean, it's really hot, so pretty close to boiling. So when I bring this water back, even though it's been in the open air for a couple minutes, it's still scalding. It still can hurt and scald your skin. So that's what all the safety equipment is for. Anyway, check out those videos. The other example for retrieval I just wanted to give you guys is this idea behind gas sampling. And I know there are a lot of payloads. So for example, the DJI Matrice 600, there are some commercial entities out there that build these custom payloads that go on the M600 for gas sampling. The U.S. Geological Survey also built their own gas sampler, and this is an image of it. This is the multi-gas sampler mounted on the Matrice 600. And these are just the calibration cylinders. So every few flights they have to hook up the calibration cylinders so that the sensor knows what the baseline is. So you basically, the way this mission worked is you fly the drone, you look for a vapor cloud, you use the camera, and so basically the way as the operator you're flying these is you fly towards the vapor, observing the aircraft. As you get close to the vapor, you sort of go eyes down, observing your ground control station. And basically, as long as you're flying and you can't see anything, so you can just see gray vapor, you're doing a good job for the vapor collection. It's the craziest UAV operation flight you'll ever do, because it's very anti-intuitive, right? You're always thinking you want to be able to see where you're going, but this is the opposite. You actually want to make sure that you can't see where you're going, because that way you're ensuring that the vapor sensor on board the aircraft is actually sensing some vapor. So really the goal here is just to give you an idea about some examples for sampling. This is definitely not, or sampling and retrieval. So I don't want to, not trying to give you an all-inclusive, hey, here are all the ways that UAVs are used to retrieve information. I just sort of want to, that first objective for the module, if you recall, is just to ignite your imagination for what is possible. And that's really the goal here.